We've put together a really, really good plenary session this year. I'm very, very proud of what we've done. We have, first of all, we have one of the 2012 Nobel Laureates, David Wineland, from the National Institutes of Standard and Technology in Boulder, who is going to give a talk about his research on basically manipulating single quantum systems. Some of Dave Wineland's work has really enabled a whole new field of optics and physics, in fact, really two. Dave's work basically was pioneering in that it allowed people to start looking at single ions and how light interacts with single ions, and it allows you to probe a whole host of physics that you can't probe under other circumstances. So, for example, one of the really emerging research areas to come out of what he did was quantum computing. All right, and this is something that continues to be very, very big and very exciting. A second thing that came out of his research was basically the study of fundamental quantum mechanics. For example, there are things called Schrödinger cat states, where atoms and light can entangle with each other and exist in sort of hybrid states, and Dave was a pioneer in looking at those states. Third, precision timing. All right, frequency standards, timing standards actually have really evolved because of the work that he has done. So it's a fascinating amount of work, and I think people will be really, really excited to hear what he has to say. We're also really pleased to have Margaret Murnane from Gila and the University of Colorado Boulder. Margaret, along with her husband, Henry Captain, run a group together there, and they have been pioneers in the areas of developing tabletop sources of X-ray sources, extreme ultraviolet sources. Right? These are really important because they have applications both fundamentally and also in technological areas. So fundamentally, for example, you can use extreme ultraviolet sources and X-ray sources to probe the dynamics of single electrons and atoms on time scales of attoseconds. All right, so this is the highest precision timing that you can do in the world. That's really exciting. It also has applications in things like optical lithography. So for example, when you use your computers, you use Intel chips or perhaps AMD chips, and they use optolithographical techniques to produce these really, really tiny circuits on these chips. Margaret's work has actually allowed that to even go further, so you can actually do things now really on the nanometer and maybe even on the sub-nanometer scale. So this is really, really exciting.